Hello everyone, my name is Dmitry and today I will tell you about SAP security and about security of SAP software development server. I said my name is Dmitry, I'm from Russia, I work in the field of information security and in particular business application security. What's more, I and my friends are the organizer of hardcore security conference in Russia, Zero Nights, so if you love Russia, you're welcome. And the company I work for is called ERP-Scan. We are the developers of ERP-Scan security scanner for SAP, and we conduct security assessment of business application, embedded systems, and mobile systems. We find various vulnerabilities in them and get acknowledgements from vendors, blah, blah, blah. And so, who knows what is SAP? 1, 2, 3. Okay, I think only for you this topic will be interesting. Okay, SAP is the most popular business application. More than 240,000 installations all over the world, but people spend enormous amounts of money to install it and then forget about security. In ERP systems, all business processes are performed, all critical information is stored like financials, HR, clients, and not to care about the security of this data is not very sensible. SAP security. What goal do the attackers have most often? First of all, it's espionage, some kind of stealing information, stealing financial information, stealing corporate secret, stealing supplier and customer list, stealing HR data. The next one is fraud, false transaction or modification of master data. And finally, sabotage, denial of service attack, modification of financial reports, and access to the technology network like SCADA by trust relationship. It is possible because SAP system is the place where all data from other system is stored and proceed. That's why it's possible to attack other system after compromising SAP. According to our research about the state of the SAP security industry science 2006, SAP security begins to receive a lot of attention in technical security conferences like a Black Hat, Hack in the Box, and other. Since 2010, this trend expands to other conferences like Hacktivity, and more companies and researchers begin to publish their research in the field of SAP security. Number of SAP security talks presented in the different conferences every year is shown on this slide. And that means amount of public information and technical details available for potential attackers. And how does SAP company, SAP AG, solve the problem of vulnerabilities, just as everyone else does? They issue patches called SAP security notes for all of their customers. Look at these diagrams closely. With the last 4 years, the number of patches has grown greatly in comparison to the year 2008. It has reached 8,000 patches a year, which makes it kind of obvious that there is more and more vulnerabilities in SAP explored early. However, it is also obvious that the number of SAP nodes in the year 2010 is larger than the year 2013. Why? It's simple enough. Yes, there are less bugs this year, but they are more critical. By the year 2009, all obvious security flaws were already discovered. It is currently not so easy to find a SAP bug, but if someone does find it, it's usually a very critical vulnerability, which allows compromising a lot of systems. In SAP world, we have a myth. There is a myth that the SAP is not accessible and cannot be attacked from the internet. This is wrong. The system becomes more and more popular, cloud service and mobile solution appears. So more and more SAP services become accessible from the internet. And we have scanned the internet for various SAP services and aggregate all this information on our site, sapscan.com. And a little bit statistic about SAP services. And The detail of this statistic you can find in our white paper, SAP Security in Figures. Okay, let's start. SAP NetWeaver development infrastructure, or DI. DI is a complex item. It combines the characteristic and advantage of local development environments with a server-based development landscape. All this stuff centrally provide opportunities to support the software, implement new features, manage lifecycle of products, etc. So the main aim is to control deployment of components in the system landscape in a standardized manner. It allows to import business package from SAP, modify standard application, or deploy new component. The infrastructure includes a range of services and provided mostly by the following components. And first of all is design time repository, or TTR. It's a repository that provides a version source, file management, all design time objects or source are stored and versioned centrally. It manages versioning of your resources and support concurrent changes of the same resource in the same repository by different users. It provides an infrastructure for managing, distributing, and large-scale application development that includes mechanisms to propagate resource changes between repositories, including change management. And the second is Component Build Service, or CBS. Is responsible for the configuration of the GDI, the administrating of the transport landscape, and for software transport within this landscape, right up to shipment of the software. It used as central archive management and building environment. Next, Change Management Service, or CMS, is used to maintain tracks and keep track of what version is developed on different servers in the landscape. In other words, creating logical development system and software logistics for all development phase with automated deployment to the runtime system. And the whole infrastructure is connected with the SLD and SMD system and tools. Software landscape directory, or SLD, plus name server. Name server guarantees the unique of object name. SLD provides management of available products and components and their names. So it is a central source of system landscape information relevant for the management of the software lifecycle. And the developer studio is SAP's development environment based on Eclipse Foundation, Eclipse platform. So it consists of everything for developing and running enterprise application. It connects to all described before system. So everything mentioned above is original developer stuff. It is related to deployment or test infrastructures. But the key component in this scheme I want to speak about is software deployment manager, or SDM. It is directly related to the product systems. That's why it's so critical. It is client-server application, which is used for installing Java EE components on the Java application server. So SDM server runs on the server side, and graphic user interface is available as a client. Software deployment manager, SDM, groups several different deployment types in a single network interface for the deployment of any software that you develop with the developer studio. To deploy software that you have deployer in the deployer studio in a local target system, and the deployer studio calls the SDM directly. But administrator can use it when they want to deploy already ready application or support package for Java application, for example. Also, developers who cooperate with the other developers can use SDM. They will be able to deploy the components developed by the other group and test the joint work of the components. Developers who deploy their application locally out of the NetWare Developer Studio also use SDM. SDM consists of several model which connects the SDM GUI user with the J2EE engine, database, and file system resources. Let's look closer at SDM server. There are two different server modes, standalone and integrate. In standalone mode, the server starts by a Java process and not by the Java control framework. And integrated, in these options, server is started by the Java control framework, and which means that it is started and stopped automatically with the J2EE engine. The SDM server accepts only one user at a time. If somebody has already connected to it, we will receive an error message. The SDM server recognizes only one user, and this user is administrator because of that's all. And SDM also use two ports, 50117, it's administrator port, and 50118, it's a GUI port. Okay, let's look at the SDM client. This is a Java application. The SDM repository stores information about the registered software company archives and software deployment archives. All this work in the term of deployment we can call just software deployment units, but I will use the word application for better understanding. So it allows to browse all deployment application by touch the system, check configuration, check logs, etc. And regarding deployment and undeployed tabs, this obviously allows to deploy new application and delete old ones. It takes you through the individual step from the selection of the application to actually deploy the software in the touch directory. And the last option is log viewer. It allows to see some several logs. And so what is important to summarize? Let's see what we have and what we can do. SAP widely uses Java services. Most of all SAP web services are based on Java application server. Login name and passwords are the similar among these services. Anybody who's a password of this user can perform an activity in the SDM. And if your logon fails 3 times, the SDM server stops automatically. You can then restart SDM server again, but if attacker try to log on 3 times, SDM is stopped. So everything mentioned above is very critical, and if attacker manages to break into SDM, he has great opportunities for backdooring almost everything related to Java in the SAP infrastructure. SDM is a fat client. What is the main difference about web client and fat client application? There are many tools for example, there are many tools for intercepting and modified traffic of web application like a Burr proxy, web inspector, etc. And so few for fat clients, especially for Java. In Java, theoretically, we can decompile Java files, perform source code review, and then use this info and also alter the code and recompile the client for performing custom attacks. But often it's very hard to do because recompiling the code generates a lot of error, plus SAP uses their own version of Java machine, and of course there are many depends. And Java have been always used as an enterprise application. So since that SAP support Java 2, and as I said, has their own Java application server that includes SAP owns Java virtual machine. And Java 6 contains the attach API features that allow seamless inter-process modification of running JVM. The attach API is an extension that provides a way for a Java process to attach to another JVM machine, JVM at runtime. This can be used to load Java agents onto a remote virtual machine. Those agents can then redefine classes or retrieve information about the JVM to which attach. Using this method, we can intercept and hook some functions in Java application. That's how we can modify input and output Java function parameters. And for this, we use a tool called Java Snoop and developed by Aspect Security. Okay, let's discuss some attacks on SDM. If attacker, as I said before, if attacker uses an incorrect password 3 times, the SDM server will shut down automatically. Also, if you send this request, you can shut down the SDM server manually. Boring. Go next. Information disclosed and assembly relay trick. It's old trick which allows to steal NTLM hash. It's a very old trick, only on Windows machine, but sometimes it's very useful. Boring. To prevent this attack, just install this SAP note and read these documents. Now I'll show a little bit interesting attack. First of all, we need to compromise some SAP services. This allows us to compromise SAP SDM service, which allows us to compromise SAP server operating system, and finally, we compromise SAP directly. Okay, SDM authentication. Let's see how authentication is in SDM works. It appears that SDM is sending to the server not the password when user is typing it in the form, but the hash of these passwords. SDM calculates the hash locally and sends it to server for authentication. On the server, this hash will compare with hash from SDM config file, and if they are similar, access is granted. It's like to store plain text password in the text config file and send from client the plain text password too. So we just our attack is we try to find on the server hash and just can use random password, intercept the call function which calculate hash on the client and replace with no hash. That's how we can log in without parole, without password. The pass hash attack here. There's the part of client code where creating hash string and sending it. This function call we will intercept. And after some experiments, we found that SDM stores user password hash in config file sdm repository.sdc. And for an attacker, there are 2 ways to get this hash: directly on operating system and more interesting way. SAP is a complex system that at any moment usually exists some vulnerability which allows us to read system files. It could be some injection. It could be a XML external entity vulnerability, server-side request forgery attack, or web tampering. And, but also possible a more easily way to compromise SAP SDM is default password for some cases. It is API SDM or SDM. Okay, now we know how we can attack SAP SDM. We just read SDM repository.sdc file, get hash password, use hash as password to authenticate on SDM server, deploy our backdoor on SAP server, profit. Cool. How we can read the SDM config file? We can use OS command execution through CTC vulnerability, XML external entities, directly traversal, file reading through MMC functions. All this attack I was described on my paper about hacking SAP portal, but today something new. It's SAP Log Viewer standalone services. What is it? SAP Log Viewer is a service which allows SAP administrator collect SAP logs and trace files from different machines. It uses 3 ports, and you can view local server with log on the remote server, interesting, and register file as log file. And what important, you can do it, all this stuff without any notification. So attack is pretty easy. Connect to log viewer standalone server, register sdm repository.sdc file as log file, read it, and got a hash. That's how look config file in SAP log viewer. And there is a hash. We got it. Okay, now we have a hash password. We can use it for authentication on SDM server. As I said before, we hooked call function with calculated hash, paste hash from config file and profit. We successfully log in SDM. A little bit later, I will show demo. When we got access to the SDM interface, it is possible to do everything available in software deployment manager. Here you see information about repositories, about component, and its settings. Here is a wizard of choosing the file from the deployment. Also, directly traversal vulnerability exists here. Here you see undeployment features. If an attacker familiar with SAP application, he can undeploy some important application. It could be considered a selective denial of service attack because user will not have an opportunity to do their job and some business processes will be stopped. But the key feature is obviously deployed application. It's possible to place backdoor into already existing application, and almost always it will be impossible to detect. This is a picture before deployment backdoor and after that. So we got access to software deployment manager. We have shell on the Java application server. So what? If we can execute operating system command, we should collect information about infrastructure, environment, etc. But our goal is SAP. To prevent, you need to install this as a node, blah, blah, blah. Great. We can execute some command on operating system. What we can do? SAP documentation says something about SAP security storage, a place where Java passwords are stored. Let's try to find it. Let's back to SAP documentation and see. By default, the J2EE engine stores secure data in the file sexstore.properties and encrypts the content of the secure store with the triple dash algorithm. Not bad. Let's try to read sexstore.properties file. We can execute any operating system command. We have our backdoor, and we know where the sexstore security storage database is located. It's all that we need. Read this file through our backdoor. It seems to be exactly what we need. Words, administrator, and password hints that we are on the right way, but just as expect, the file is encrypted. We have to find a key, but where's the key? Surprise, surprise, the key file located in the same directory, and we also can read it. With an encryption password and the key for decrypted, we can get administrator user password of SAP system and successfully log in SAP. To prevent this attack, just read access to the file sexstore.properties and sexstore.key. And a little bit about post-exploitation. When you log in as administrator, you can do anything, but as I said before, to compromise, for example, other system, just typing in search something like super secret or password, and you find a lot of interesting documentation with stored passwords. Okay, little demo. second. Okay. We have a SAP system, but we don't have a login and password. It is bad, but we have a SDM on the system, but again, we don't have a login and password. We don't have a password. And again, on the server, we have a SAP log viewer standalone services, which allow us to read log file from any log file from the server. It's loading. Okay. By default, we can read only local file, log file, but if we point any SAP system and point a port of standalone log viewer, we successfully connect for them and point any file as log. In our case, is SDM config file. And we can successfully read it, and I got hash password. Save them. This is a Java Snoop, which allows to intercept function on the client. In this case, we intercept the function which send on the server hash string, and we replace unknown hash and paste hash from the server, from the config file, accept changes, and here we go, we administrator on the SDM server. Okay. Now we can deploy, undeploy, view some logs. For example, deploy, we can deploy only on one specified place in bar catalog, inbox directory. But again, we can intercept something and try to traverse // add some changes and got a file system tree. Okay, not bad. But now we try to deploy something. Something is backdoor. Select our backdoor, which looks like SQL trace services. And now I show on this server don't have a backdoor. Nothing, and when we deploy, the deployment is very easy. Next, start the deployment. Okay, confirm, yes. and refresh page. Bingo, GSP shell, cool. Now we can execute something, for example, ipconfig, it's work, and try to read a file with encrypted password, security store.properties. There is encrypted password here. Save them. And now read a key for decrypt this password. The key located in the same directory. Very secure, yes. Okay, save both this file, and I wrote a tool. There is a 2-hour file. I wrote a tool which decrypt the passwords and just launch the tool. And got decrypted strings. And now we can use decrypted passwords for connection as administrator. Okay. In this demo, my password has expired, but the demo shows we can change the passwords, but I did it. Okay, we added administrator on the SAP. Thanks. After that, we can do anything with the systems and compromise other systems with trusted relationship and blah, blah, blah. So, conclusion. Security is a complex process and requires to pay attention to different areas. So if you care about SAP security, don't forget it. SAP guides regular security assessment, ABAP code review, segregation of use, a lot of problem in SAP. And if you want to know more about SAP hacking trends, just follow our future presentation site and Twitter. Thank you very much.